All right, welcome to Module 1 of COP 2360, a first program using C#. This is programming in C#. I will say that if you are not taking my course, that's totally fine. Welcome anyway. Let's get started. All right, so what's the process of programming? We have two different things that we need to talk about. The first thing is we have what's called software. Software is basically a set of instructions that tell our computer what to do. And those instructions can be written in any language. They can be written and run on any PC. Normally, that's how PCs work. All right. We have another category called hardware. Hardware is normally what we use to interact with our computer with what is known as human-computer interaction. Now, if you're using a tablet, obviously you don't really have anything to interact with your computer with other than your finger. So really the tablet is the hardware. But if you have a PC, then you'll have like a keyboard and a mouse and maybe other devices that help you interact with the computer in some way, shape, form, or fashion. That's called hardware. So once again, software is a set of instructions or programming statements that we use to run, whatever we need to run whenever we need to run it on our computer. And then we have hardware. Software comes in two major categories. We have one category called operating system category, and our operating system is exactly what it sounds like. Most of us cannot live without running an operating system. Normally, our operating systems have a lot of bells and whistles, normally a graphical user interface, otherwise known as a GUI, that allows us to see what the computer is trying to tell us in a way that makes sense, point and click, things like that. That's what a GUI is. When your latest Windows 11, your latest Mac OS, even your Android OS, all have graphical user interfaces that allow us to interact with our computer in such a way that makes it easier for a human to interact with the computer without having to know a specific set of commands to run. You also have operating systems that are very minimalistic, operating systems like the minimalistic versions of Windows Server, MS-DOS, minimalistic versions of Ubuntu, Linux, things like that, where you have to use specific run line or command line commands to get from point A to point B to do certain things, right? But no matter what you do, you can't get away from the idea of an operating system. And the operating system is basically a framework that allows us to interact with the computer in such a way that makes sense to us and the computer. That is the bare bones foundational point of running your computer in and of itself. An application is what is built into the operating system that allows us to do more things than we could have done without it. So for instance, back in the day with MS-DOS, you couldn't do a lot of things that you would normally like to do without maybe a text editor and things like that. And we've progressed from text editors to Lotus Notes to yada, yada, yada. You could talk about all the office suites. They're normally the bread and butter of application software that we discuss. But if you're working for an organization like Amazon or a big bank or an insurance company or even a small mom and pop shop, they also have specific applications that you would write there to automate the processes happening in their domain. So if you ran a pickling shop and you pickled fish, you would have applications that are built to support the domain of pickling fish. You're not going to write an operating system. That would take way too long, but you would write a small access application, or you might write an Excel tracker, or if you have the chops, you might even build an application using Node.js, TypeScript, and maybe your framework of choice, Angular, React, Vue, and then push that up to a web server so it can be promoted and serve your customers in a way that is advantageous to them. So application software can come in many shapes, forms, and fashions. Just understand that application software runs on top of an operating system. Now, you might be saying, wait, a website runs on top of an operating system? Absolutely. A website is more than likely going to be hosted by a web server of some kind, Dockerized or not. And what that essentially does is it promotes that information to the client machine. So those client machines can be served by the server the information that they need. And if the client needs to communicate with the server in any way, shape, form, or fashion for any request, then they can do that then and there. And that is in and of itself still application software run by either, some type of web dynamic framework that was written. Like I said, I use TypeScript as an example, but if you're using a high-level language like C# or Java specifically, then you can use Microsoft's .NET framework or .NET Core to build a model view and controller, or Java's framework when it comes to Maven to build a website using Maven. Now, in this class, we're not going to talk about Java. That's in my Java course. But in this specific class, we are going to go deep into the weeds about what C# can do for us as far as .NET Framework and .NET Core. C# is mainly just a language. .NET Framework and .NET Core are the things that you're going to need to understand when you get to the real world. In talking about that, let's talk about what a machine language is. A machine language is a language that communicates directly with the machine via the CPU and the kernel. Now, I'm not going to get too deep into the weeds about how that works or what that means, but please understand that machine language is normally not understandable to a normal human being. Normally, when you see machine language, it is in the form of hexadecimal binaries or binary numbers to begin with. Now, why is that? Well, when you get to the nuts, the foundational points of computer science, the foundational points of computer science are really where electrical engineering comes into play. And when you look at your motherboard, your CPU, and everything that your computer is running, right? Even if you're in the cloud, those things still exist. What is happening at that level? Well, when your CPU does a computational cycle, it is basically comparing two things. And it's asking itself a very simple question. Is this true or false? Is this a 0 or a 1? Now, a 0 means that there is no electrical pulse and it is off. A 1 means that it is on, meaning it's true. The electrical pulse is present, so it is true. Now, at its very minimal, the foundational point of this, it doesn't make any sense, right? But if you're running a video game like Elden Ring or you know, anything else that is very much so processor intensive, you might be running millions of processor cycles at the GPU and CPU level per second. Now, that goes without saying. You might be thinking, wow, that's insane. That's a lot of processing. And it is. Because in order to get your computer to promote the frames per second necessary to play the game with some type of fluidity, you need your processor to be somewhat beefy and to be able to compute true and false expressions almost at the nanosecond rate, which is the norm nowadays. Given the fact that we can combine processors within the same CPU, so that we have logical threading at the processor level. Not going to get into that. Not going to get into that. That is literally way too deep into the electrical engineering side for me to want to talk about in this case, because this class is all about application software and application development and using C#. So what's the process of programming? Oh, I'm sorry. We talked about machine language. The next step up from a machine language is assembly language. Assembly language is a clearer way of writing programming language that can be compiled down into or interpreted into machine language for the kernel to read. Assembly language is still not easy to read if you're a normal human being. And then you have high-level languages like C#, Java, JavaScript, PowerShell, PHP, CSS, things like that. These are, well, CSS is not a high-level language, but a high-level language that you can write programming statements within that can be compiled down. PHP is also not a high-level language. I apologize. COBOL, Fortran, that you can compile down into machine language via assembly language to be processed at the CPU level. Now, with all that being said, there are some things that denote what a high-level language is versus what an assembly-level language or a machine-level language is. The first thing is using reasonable keywords such as read, write, or add, instead of sequencing on and off switches. And this is very important because machine language tells the CPU what to turn on and off, whereas what our high-level languages do is it tells the CPU what it needs to do. Hey, I want you to read these collection of memory locations, right? That's a fancy way of saying, I want you to read this array, right? The array sits in your random access memory in a contiguous fashion. Remember, we haven't talked about it yet, but random access memory saves things to it randomly. And what we need to do with arrays is to save to our random access memory in a contiguous form, meaning that they're right next to each other, so it is easy to retrieve. To be quite honest with you, a collection such as an array or a collection such as a list are the fastest forms of collections you can have instead of having multiple variables, right? You know, right now what we're going to do is we're going to build a lot of variables until we talk about arrays. But please understand that an array is far more efficient than a variable because a variable is saved to your RAM randomly, and the computer has to then randomly find it and bring it back, whereas the array is not saved to your RAM. The array positions or the things that are in the array are not saved to your RAM randomly. The array itself is. So all the computer has to do, or all the CPU has to do, is find the array. And once it finds the array, all of the sequential things that are in the array sit in your random access memory one by one next to each other. So it doesn't have to find all those values individually. So you will find that I will more than likely err on the side of caution and force you to not use variables nearly as much as you would use a collection, an array, or a list. A compiler takes your code that you write in high-level languages and it creates machine language out of it for your computer to run. Now, if we were using Visual Studio in this course, you would have to compile your code, but because we are using REPL, REPL compiles it for us. Now, what is a syntax error? A syntax error is something that a compiler is very adept at catching. Syntax is the grammatical form of your code. It's the way the code is written, right? So if your code is written incorrectly, then you will get a syntax error. Now, when I say incorrectly, I mean that grammatically, it is not syntactically sound enough for the compiler to be able to create the machine level language that it would need to run to make sure it runs correctly at the machine level. No, what's actually happening is the compiler said, hey, I don't understand what you just wrote here because this is not possible. That is what a syntax error is. You can think of a syntax error like a grammatical error in a regular language. So instead of saying the car is red, you can say the car of red, I don't know, mess up a sentence in some way, dat instead of that, or something like that. You can actually syntactically, us as humans, we syntactically handle those exceptions and say, I understand what you're saying. But if you were speaking to someone from another country who was speaking English and we used Ebonics, or we used some other form, some other English colloquialism, if you will, that they might not understand, then their compiler, okay, their internal compiler is going to say, what is this? I can't translate this into normal language that I would understand to be written English, right? So for instance, if you had somebody from, inner city New York speaking to somebody from inner city LA, they may not have as many compiler syntactical errors in their mind as if you had somebody from New York speaking to somebody from Texas. Let's take, for instance, somebody from New York City, inner city New York, speaking to somebody from Brisbane, Australia. There may be a lot of syntactical compiler errors going back and forth, or London for that matter, the idea of a lorry versus a truck, or the telly versus a television. Now that one's close. So the compiler might be able to say, well, maybe that means what I think it means. I don't know. But there's other things that just don't jive well. If a New York City person said, hey, I'm going to the bodega, there's a good chance that somebody who just only lived in London, they've never been to New York, and they've never ventured out, they've never read any documentaries, or they've never done any research, would say, what is a bodega? Where are we going? That sounds very exotic. And they can say, it's the corner store, man. That's where we're going, the corner store. And they can say, oh, then why don't you call it a corner store? Because it's called a bodega here. Oh, well, you should call it a corner store. No, you should call it trucks. You should stop calling trucks lorries. They're trucks. You see what I'm saying? So that's an interesting argument, right? Because in regular language, we have the same problem. You will find out that you will become very linguistic when it comes to programming languages for that very reason. All right. Next up on the chopping block, the process of programming 3, programming logic and debugging. Programming logic is really the way your statements are formed, not the way they're written, the way they're formed, and the way they interact with one another. So you may have a couple of statements that you're writing because you want to go out and get data from a database, and then you want to present it on your page because a user said, hey, this, that, and the other thing, I want this. Well, in order to do that, you would have to write a series of programming statements or procedures that we call methods in C# to go out and get that information. Now, debugging is the process of looking through your code line by line as it is running, all right, to find out what's happening. Normally, when you debug, you are able to not only parse through your code, but you're also able to figure out what's wrong at that point in time. Debugging is a very tedious task. It is necessary, especially if you don't have any idea what's going on in the code base that you're writing. So for instance, let's say you just joined the team, and they're like, hey, you need to go on to the web page and you need to make sure that the data that's presented there is the data from this table and not that table. Okay. That doesn't sound very hard. I've done this before, but I don't understand how they wrote their code because there's multiple ways to do this. They might not have written an Entity framework. They might have used IDEO.net. They might have just written SQL statements directly into the code. I have no idea. Let's find out why. And so we sit down and we debug what is happening right now. Go onto the page, turn on the debugger, run it. And then you just step through the code to find out how it's operating. And then ask yourself a series of questions. Hey, where in this code can I interject what I'm trying to do, and how do I do that? That is the complete process of debugging. Because we are using REPL, debugging is not as apparent as it would be if you were using Visual Studio, but if you would like to use Visual Studio, you can. So now that we've gotten out of the process of programming, let's talk about procedural programming using object-oriented programming. What is object-oriented programming? Object-oriented programming is literally a programming framework, a programming paradigm that allows us to develop our programs in a way that is uniform across the board. There are 4 different types or 4 different precepts and concepts of object-oriented programming. And you've probably heard of them before, as well as the other offshoots of OOP. I will be saying OOP from now on because object-oriented programming is a mouthful. OOP in and of itself spawned in the 70s when we found out that our code was becoming very spaghetti. There wasn't a lot of understanding of why it looked the way it did, and there were a lot of engineers and developers that were writing their code for job security, which made it very hard to figure out what the hell was going on. So what OOP does is it standardizes what the code is supposed to look like. The 4 different precepts, the 4 different ideas within object-oriented programming is abstraction, encapsulation, polymorphism, and inheritance. All right. Now we're going to go over those again. I have slides for those, but for now, I just wanted you to hear the words so they're fresh in your mind and you're familiar with them. So the first thing you need to understand about an object-oriented programming, or OOP, is that it is a collection of objects, and it uses objects to run the programs that we write. Now, what is an object? An object is a real-world instance of a class. That's it. All of this is right, but really it's just an instance of a class. You will from now on hear me say the word instantiation, because instantiation means an instance of, and I don't want to say an instance of because that's a mouthful. So if I wanted to instantiate a class, I'm literally instantiating the object, or I'm creating the object out of the class. Now, think of an object like a real thing. It is real. Now, an object is a thing. I said this in module 0. An object is a thing, but it is the thing you want it to be. So if I wrote a class called car, when I instantiated or created the object from that class, I would have an object of car. Now, what does that make a class? Well, a class is nothing but a blueprint. A class is nothing. It's just instructions. This is what the object should be when we create an instance of it. This is what the object should be when we create or instantiate it, okay? When we instantiate the object, this is what it should be, and that is what's in the class. If you would like the instantiation of the object to change, then you will need to write that into your class. When you instantiate an object, it has the properties of the class. So if in your class you wrote constructor statements, then it would be in the object. If you wrote properties, it would be in the object. If you wrote methods, those specific methods, if they are public, would be in the object, and they would be usable by the object. Now, there's a very good reason why we do this. We do this because not every object is the same. So think of a class like a factory. Think of it like a car factory. You have a car factory at Toyota or a car maker of your choice. And that car factory pumps out cars at the cyclic rate. As a matter of fact, we'll talk about a Toyota Camry. Okay, so the car factory is the class. It contains the blueprint for creating Toyota Camrys. When we would like that factory to create a Toyota Camry, we would tell it, I want you to instantiate an object of Toyota Camry. And the factory says, sure, here you go, bam. Now we have Toyota Camry 1. Now we go back and say, I have another customer who wants a Toyota Camry. The factory goes, oh, great, bam, here's another object, object 2 of Toyota Camry. Now I have 2 objects. They are of the same type, Toyota Camry, but they are not the same because they are different objects. Now, why is that true? Well, maybe customer 1 wanted some things that customer 2 didn't want in their Camry. Maybe customer 2 didn't want things in their Camry that customer 1 wanted in their Camry. If these 2 Camrys were one and the same, whenever I changed customer 1's properties, maybe they wanted leather seats, then it would also change customer 2's properties. They want leather seats too now because they both are one and the same. They're not separate objects. What's even worse is if they're not separate objects, when customer 1 decides to drive their Camry, they will also be driving the second Camry at the same time because they are linked and static. We don't want that. So what we do is we create 2 separate objects so that when customer 1 wants to use the Camry in their way, it doesn't affect customer 2. That is how object-oriented programming works in a very high-level nutshell. And you can make this even more specific to computer science, talking about website design. If one customer goes to a website and they start shopping, and customer 2 goes to a website and they start shopping, customer 1 now instantiated their cart, right? Customer 2 instantiated their cart. These are 2 separate objects. They're 2 separate collections, if you will, right? If customer 1 and customer 2 did not have separate objects and they shared the same object, when customer 1 put things into their cart, they're also putting things into customer 2's cart. And when customer 2 puts things in their cart, they're also putting things in customer 1's cart. This is bad. This is bad. You don't want this. You want separation so that when customer 1's so customer 1's experience is singular to them. That's why we use object-oriented programming, because it allows us to do that simply. It gives us a standardized way of compartmentalizing the two objects by themselves. So when we look at the object-oriented approach, it's important to understand that defining the objects needed to accomplish the task is super important. Now, we can get object crazy, and that's really bad. But what we want to stress in this situation is that objects themselves are not bad. Now, OOP was originally used for two types of applications: video games and GUIs. And we still use it today for a lot of other things as well. Now, for a language to be considered an OOP language, it's very important that that language have a few things: classes, objects, which constitute abstraction, by the way, encapsulation, inheritance, polymorphism. So, what is abstraction? Abstraction is what objects do. Now, you would find in this textbook, they don't talk about abstraction all that much, but it's the singular most important part of object-oriented programming. It is not implicit or inherent. It is not baked in. It is baked in, but it's not something that is unseen. So if you think about the analogy here, I'm going to read this off so it makes more sense. Objects in an OOP language provide an abstraction that hides the internal implementation details. You do not want your user seeing what you do. So think about the car analogy again. Get back into one of the Toyota Camrys. At this point, it doesn't matter. Pick one, right? Now you're in the Toyota Camry object. You want to start that car. When you start that car, you either push a button or you put your key in the ignition and you turn it. At no point in time do you know or are aware of the internal combustion of that engine, how it operates, what it's doing, what it's taking. You're not seeing the gas flow from the fuel tank through the pump, through the fuel lines into the atomizers or the fuel injectors and into the cylinders to be exploded. You don't see any of that, and you don't have to affect it. You don't have to do anything. You are literally just saying turn on, boop, and the engine turns on. It should actually. Now, if something doesn't work, then you have to debug it. But if it works fine, you don't have to debug it. You can just turn it on and go, okay, the car works, great. I go on my merry way. We do this on a regular basis. You get in your car without skipping beat and just turn it on. Now that's abstraction. The object of the engine is hidden to you by the object of the ignition. The ignition sits in front of the engine almost like an interface, and it says, hey, you don't need to see what's going on back here, and I don't want you messing with it. As a matter of fact, there are some car manufacturers that encapsulate that object. We're going to talk about encapsulation in a second. They encapsulate that object of the engine, where even if you wanted to go debug it, you couldn't, because it's behind lock and key. Mercedes does this. If you go and look at a Mercedes engine, lift the hood and look at, there's an actual lock on the engine. You cannot get in. Your car, you can't get in. You have to go to Mercedes. They have the key. They'll unlock it. They'll do the debugging, and then they'll pay you. They'll make you pay an arm and a leg for that. So second bullet, similar to the coffee machine in your kitchen, you just need to know which methods of the object are available to call and which inputs parameters are needed to trigger a specific operation. You don't need to know how the coffee's brewed, how it's working. I mean, you might be interested, you might be intrigued. Go watch a housemaid, so you don't break your machine. But you don't need to understand how this method is implemented and which kinds of actions it has to perform to create the expected result. So when you instantiate an object, it may have properties and methods already built into it that you may never know how those properties operate. Heck, there might be properties and methods inside the object that you won't even be able to access because they're private. And the developers do this on purpose to keep their code secure, so it's not easily modifiable after compile. So what's an interface? Well, an interface is an interaction between a method and an object's exposed behaviors. An interface is an abstract layer of your code. It sits in front of your class, and for the most part, it forces the user to have to interact with this interface versus what's behind it. This is not inheritance, so I'm going to talk about what inheritance is. Inheritance, and just so I get the textbook definition of this, so that we're all on the same page. Inheritance is the means by which things are familiarized between what is in your code and what isn't. So think of inheritance as the ability to have a parent-child relationship in your code. That's it. And inheritance is very important because the parent can share their properties with the child class so that the child class itself can do more specific things than the parent can. Think of it this way. Normally in inheritance, you have a parent class. So we're talking about cars. So let's say vehicle. Vehicle is the parent class. And in vehicle, you have a lot of properties and methods that are generic to a vehicle. But how many types of vehicles can you have? Well, there's an airplane, car, truck, semi-truck. There's like different types. These types of vehicle will inherit from the vehicle class what is common across all of them. And then specifically in their class, speak to the specifics of what a car needs. A car does not need to tow things, but a semi-truck or a truck do. So in the semi-truck or truck object / class, you might want to have a towing capacity. Airplanes don't tow stuff, so they might not need that either. I mean, I'm saying they don't. I have no clue. I've never seen it happen. And if they did, that sounds excessively dangerous. But then again, helicopters could tow things, right? So maybe airplanes are wrong. I've seen helicopters tow water to a forest fire and drop it in. So theoretically, I'm wrong. Yes. So this is where things get more specific. And then from the airplane class, there might be children underneath that one. A Boeing 727, 737, 747, helicopters, whatever. And then those can have their own specifics inside them. They inherit from the airplane class, which is generic or common across all those airplanes, if you will. But each airplane may be different in the capacity that they can carry, in how fast they can fly, and the fact that they can tow, what fuel they use, yada, yada, yada. We have encapsulation, which I've spoken about not in great detail, but encapsulation basically takes the code that you write and it makes sure that it is completely and utterly not viewable, unviewable. That's it. So you might have code you've seen that has method on method on method that's being called. That's called encapsulation. It's almost like a babushka toy from Russia, where you open the toy, there's another babushka inside, you open that toy, there's another one inside, you open that toy, there's another one inside. You just keep doing that until you get to the code that until all the code runs what it's supposed to run. This feels like spaghetti, but it's not. The whole reason why we do that is because, like I said, there's offshoots of OOP. One of the offshoots of OOP is SOLID. If you want to look up SOLID, it's SOLID. It's an acronym. And SOLID has 5 different, very specific object-oriented programming techniques that we use in the real world today to get us to this point in encapsulation. And one of those is single responsibility. And what single responsibility does is it allows us to take the code we are writing and ask ourselves a singular question. The class for car. When would I need to make another class? When the methods or the properties that I'm writing in that class do not match with the class car. You should not have a print method in your car class. You can override a print method into your car class. That's totally fine. But you should not be writing print methods into your car class. That shouldn't be there. That should be in the print class. Now, this sounds really very rote, very simple, but the simplistic nature of what I'm saying is inherent. You have to stick to these rules. And finally, we have polymorphism. This is the one part of object-oriented programming that a lot of developers, I don't care how long you've been in the industry, it's lost on people. Polymorphism. And polymorphism is the ability to create methods that act appropriately depending on the context. Or more specifically, polymorphism is the ability for the computer to automatically select the method and or class it needs when it needs it without user input. Right? So if somebody goes to if somebody goes to like a dealership website and they want to see Toyota Camrys, they should be able to click that. And the computer on the back end automatically knows what to select. Not, oh, I've mapped it all the way to the Toyota Camry object. No. What I'm saying is that when that person clicks that value, the computer determines, oh, you need Toyota Camry. I'm going to take you there. It's almost like a router. Now I'm talking about it in large terms. I'm glossing over some very key facts that are super important in polymorphism, but this is just an intro class, and I don't want to take too much time talking about it right now. We will talk about it as the class progresses. So let's go a little deeper into C# as a programming language. It was developed as an object-oriented and component-oriented language. Very important. C# and Java were both developed almost at the same time, and it's part of the Microsoft Visual Studio package. Please understand that Microsoft Visual Studio is the primary interactive development environment for C#. REPL is literally the only program I've ever found that also does this, or Visual Studio Code. But if you're going to write C#, you might as well write it in Visual Studio. In this class, we're going to write it in REPL so that you don't have to deal with Visual Studio. And the rest of this you can read on your own time. I've put this slide up. All right. Open up your IDEs. It's time to develop. So let's go over this real quick, and I will let you guys have the rest of your evening, day, whatever time it is. Okay, here I am in REPL. This is the same REPL that I used when I was doing Module 0, and I want to start from here and work our way forward. So we're going to start at the top. What is line 1 stating? Well, using is how we reference libraries. Let me turn on my light. Using is how we reference libraries that we need in our code. This is called a namespace. So what this is called here is a namespace. All right. Using is the keyword. Okay. And this right here on the right of using is the name of the library or the name of the namespace we want to pull in. Now, it's very important that we pull in the namespace we need so that when we write our code based on what someone else has compiled already as a library, we can use that. System.console.writeLine. The system here is implied. Watch this. If I put system here, what this should do is deprecate it and say it's already used, I don't need it. Now in Visual Studio, it would do that. Here it won't. But just understand, system doesn't have to be written anymore because, well, I already have the library imported. I already have the namespace imported as a library so that I can use that system library method, the static method, console.writeLine, right, to write to my console. Now it's upset. S console does not exist. There is no S console. You're having a giggle. You're having a funny? Whatever. I think it's having a funny. All right, cool. So let's keep going. So right now we just have class, but in a perfect world, what is before class? It's our access identifier or our accessor. Now, when you do not define the accessor, normally the accessor here is either internal or protected. And that's dependent on what version of .NET you're using. In this case, I'm going to go off on a limb and say that the actual one is internal. Now, we're not going to talk about internal or protected because those are high-level access identifiers. But what I am going to say is there are 3 access identifiers that you should know about at a bare minimum. Public is one. The public accessor, or the access identifier, allows this object, which is the class at this point, it allows the object to be accessible to everything within this project and everything outside of the project. If I change this access identifier to private, that means that this class, if it was ever instantiated, which at this point can't be without some jiggery pokery, is only accessible to whatever is inside that class itself, right? Or the class that it is contained within. You can do partial classes. And then finally, protected means this class is accessible to everything inside the product or project itself. Now, I keep saying the word project. Please understand that these are in its project. You see CS project here? It's in a project. If you wanted to add another class, you can literally just come here and add another class. We'll add this. Now we're going to name this something that makes sense, car.cs, and boom, now we have another class, but we're not going to go there right now. We're still talking about what's here. This is our class name. Now, because this is a console application, I encourage you with all due haste to not change this name ever and none. Once you create your base project, leave it the same. Do not change it. Keep it the way it is. This name right here should not change because this is the main class that your program is trying to run when it first starts up because it's a console application and it contains your main. All right. So now let's talk about the next one. What is this again? This is called an access identifier or an accessor. And what it does is it allows us to tell the program the level of accessibility of this specific component or object. Now, I'm going to say the word component here because this is a method, all right? And the reason why I know it's a method is because it sits in the class. Please understand that in order to write programming statements, you cannot write programming statements directly into the class. It'll throw an error. You can, however, write variables and methods in this class. So if I said int counter equals 0, that is totally fine. I am allowed to do that. As a matter of fact, I can call that here, and it should let me do it. I think I have to make this static. Yep. And there, I can call the counter. So the only things that can be written directly into the class, and the class starts at this curly brace and ends at that curly brace. You see how they both highlight each other? I can only write variables and methods into this class, into any class, okay? So what you're seeing here is a method that is public. Remember, there are three main types of access identifiers. Public, which means that this method is accessible to everything in this class, everything outside of this class, and everything outside of the project. Anything and everything can access this method and run it. Private, which means that only the things inside the parent object or the parent component can access this. So if this was private, okay, this class is the only place. Everything in this class can access that main, but anything outside of this class can't. If I tried to run this, I would get a very gnarly error. And the reason why I would get an error is because this main method, which is run first by the program, is not accessible. It's just not accessible. You can't access it if it's private, and it's taking some time. So I'm going to keep on going while we're talking. Oh, it did access it. That's interesting. It should not have. I think this isn't updating fast enough. And then protected. Okay. The next word, static. Static literally means you only have one instance of that thing. Static means you have what's called a singleton. You only have one instance of that thing in your program, period. So there can only be one instance of it. That's what static really means, which also means you cannot instantiate it because it's already been instantiated at runtime. I'm going to say that again. Static means you only have one of that thing, object, or component. It is already built at runtime, and you can't instantiate it because there can only be one. It is the effing Highlander. That's what static means. Static is bad. Don't use static ever if you can avoid it. It is not always avoidable. You can't always avoid using static. There are some situations where you can create singleton instances, static instances. We used to do this a long time ago. But in today's day and age, dependency injection took that need away, and now you can create singletons and dependency injection, and that is far better than creating static anything. So please, please, please stay away from static. In this case, it is unavoidable. This has to be static. There can only be one main method. If there's more than one main method, guess what happens? The computer doesn't know which one to run. There can only be one main method because this is the first thing the computer hits in the stack trace when you run it. What does void mean? Void means that this method is returning nothing. This method returns nothing. So if I wrote another method that said, print or private string name, cat name, and I said string first name, string last name, and then I said return first name plus last name. All right, what's happening here? Well, let me go ahead and change out my name here with that method. And it's not static, so it's going to throw a hissy fit, so we're going to make it static. Everything in your main method, or your main class, has to be static. So this is why I'm not a fan of static. I hate it, but whatever. So I made a method called concatenate. And what that method's going to do is it's going to return a string right where I called it, here in line 5. Okay? It's going to get to that point. It's going to return the string. And then it's going to return whatever I told it to return. In this case, it's going to return the first name with the space in the middle and the last name. This is called string concatenation. String concatenation at its lowest level, okay? There's also what's called string interpolation, which is concatenating without using plus signs. But right now, we're going to do the bare minimum. I'll show you string interpolation later. String concatenation is when you take two strings and you add them together to make another string. You cannot modify strings. Strings are immutable once you create them. These strings are immutable, which means that you cannot change them once they're created. Because they are immutable, you have to add them together to make a new string. So what's happening here is that this concatenate method is accepting two arguments that I have provided as string literals. I'm doing this very fast, but it's recorded, so you can rewind it if you need to watch this with the notes from the book. okay? But string literals are strings, right, that happen to sit between two quotes, two double quotes. Normally in C#, if you're using a scripting language, you can use single quotes. And this string literal is what I'm sending to the concatenate method in the form of arguments or parameters, if you will. And I'm going to use those as variables in the method to return a value. Now, I'm doing this for a reason, because remember what I said. Void means you're not returning anything. There is no return statement in this main method because it's not returning to anybody. The main method is the first and last method that's going to fire in this program specifically, which means that my main method has no one to return a value to. No one in the stack trace. I'm not saying the user, but we're talking code specific right now. And even if I wrote a return in here, it wouldn't work. It would tell me to go pound sand because it's void. If I try to change this to a string or something like that, this would not run right. It would throw all kinds of gnarly errors. So in this case, we're not going to return. We're going to say void, hey, main method, you're not returning anything. Your entire purpose in life is to run the code. So now what's going to happen? Well, if I run this, I should get hello world. Francis Fiske is here in this console.write line down here. Now, while that's going, I'm going to keep on going. So void means nothing's being returned. If I want to return something, I need to denote the data type I am returning. We're going to talk later in later modules about what the data types are. And here you go. Francis Fiske is here. It worked. So with that being said, that's how void and that's how the void modifier and the data type modifier works in your method. This basically tells your program what the method is returning, the data type, right? The data type that's being returned. If no data is being returned from your method, then you're going to put void. And there are situations where void is completely viable. The name of your method, in this case, main, and down here I use concatename. Please understand that I use the word concatename as the method name. It is a verb. It is a phrase. Your method names should be phrases, actions. Your method is an action. It is not static, which means that you shouldn't say name or first name here. This should tell your other developers what's happening. Concatename. Okay, it's concatenating these two things. Great. So you don't want to write a lot of comments. What you want to do is you want to write your variable names, your class names, and your method names in such a way that it's easily identifiable and understandable by the folks that are writing the code with you. You also have your arguments. So these are arguments and or parameters that are being passed into your method. If you want to pass arguments and parameters into your method, literally, you just do these parentheses and you start going at it. All right. Variables. Let's talk a little bit about variables. So variables are interesting because in C# you can just say var. And I encourage it. I absolutely encourage you using the word var because var allows you to do certain things or it allows you the flexibility to do things you wouldn't normally be able to do. But let's talk about certain variable types. You have var, which is generic, which means that it doesn't have a data type, right? So if I said var full name, notice how I typed that. I typed it in camel case. That means the first word is all lowercase, and every subsequent word after that, first letter is uppercase. This is how you write your variable names. And it's a noun, full name. It's not a verb, it's not a phrase, it's a noun. Sometimes your variable names might be very long, and that's totally fine. You just need to make sure that it's a noun and it's meaningful. You can say concatename. I can save the output of this variable first if I wanted to, just to check that it's working right before I actually try to dump it into the console.write line. I'm having a giggle, right? So now we have concat Francis Fiske. It's not concat, it's concat name. Sorry. All right. Boom. Now full name has it. Notice that now it's saying it's a string. Why is it saying that that variable is a string, even though I didn't say it was a string? I said it was a variable. The reason why it's saying it is a string is because the concatename method is returning a string. So it has to be a string. Now, this is how this normally works. I could actually say string here, and that's totally fine too, but I want you to get used to using all the different declarations so it makes sense, okay? Notice something else I did here. I did not write string full name. I didn't declare string full name and then assign it a value. I initialized it, which means I declared it and gave it a value at the same time. This is best practice. You do not want variables sitting out in the wind by themselves without data inside them because it's basically taking up a memory location without actually using that memory itself. And that is completely bad. In this case, right, there's something else I can do. And there's something else I would do in real world. I would not use var and I would not use string. You see, this name isn't going to change. unless somebody else runs the program. So I would say const. Now, there are some issues with the word const. Const normally has to exist outside of a method. So in this case, var works just fine, but I would actually have full name sitting outside the method and fill it first. And then if I wanted to use full name inside of my string, I would just type full name here, and then I would run it. And it should give me what I'm looking for. 3, 2, 1, go. 3, 2, 1, go. You can see how the CPUs have and you look, it worked. So this is all I really wanted to show you. I'm going to stop the share here. I want to say that this is all of module 1. Module 2 should be coming soon. So as I say in all my videos, good luck, have fun.